So very good morning, students. Welcome to IIT NEET Foundation Program or Focus C from Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participant branches so far for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 6th. Our ongoing last chapter, that is chapter number 7, last chapter, pressure. Of course, today we are in the almost the revision session, review session. We are going to review the chapter pressure, which we already completed in the last class. Entire concept parts. Today we are going to revise what we learned in the last 4 sessions about the physics, that is pressure. Right. So before going to learn about that, first we can recall all the slides, what we learned in the last class, right? So as we move forward, we started learning with before learning about the pressure, we started learning about what is force. So these are the topics what we already covered, which are there in our material, chapter number 7. See here, we learn about what is force. We start with force because before knowing about pressure, we should know what is force. Force is nothing but force, that is pressure is nothing but force by area. That is the reason we learn about what is force, what is area, what are the units of this force and area. Then a special type of force, which is acts perpendicular to the body. The force acting perpendicular direction is called thrust, right? Then we enter the what is a pressure. After knowing about force, area, and thrust, we define the pressure as either it is a force by area or thrust by area. Then we have seen what are the applications of pressure, where pressure is applicable in our day-to-day life. There are so many examples are there where pressure can be applied on solids, liquids, or gases also, right? Then we have seen the mathematical expression also for the pressure. P is equal to HdG. We derived from the definition of force. You can get this pressure only you can get. H is the height, D is the density of the either solid, liquid, or gas, and G is the acceleration due to gravity, right? Then we have seen what are the laws of fluid pressures, means how many types of fluids are there. Gas and liquids and gases together called fluid. So they exert pressure. There are different types of pressures exerted by liquid: upward pressure, downward pressure, lateral pressure, and all, right? Further, there is some factors are there. On some factors, the pressure exerted by liquid or gas depends. Those factors comes under laws of fluid pressure. Then lastly, we discussed about what is atmospheric pressure. So pressure not only exerted by solid, liquid, gas, even atmosphere also. Atmosphere is nothing but a thick blanket of air surrounding the earth. That air which contains so many water molecules and dust particles and all, that also exerts pressure. And the pressure exerted by atmosphere is called atmospheric pressure, which can be measured in millimeter or centimeter or meter of mercury with respect to mercury. Why? Because we will use a device called barometer or manometer to measure the atmospheric pressure. That's what we learn in the earlier classes up to total atmospheric pressure. You can see here thrust, pressure, right? Then we learn about what is the unit of pressure, what are the applications of pressure, how they are skating. While skating, why they are using the different types of shoe, what happens when you use the ordinary shoe, because area impacts a lot. Greater the area, lesser the pressure. Then we enter a second synopsis, fluids, both gases and liquids, how they exert pressure. You can see here, upward, downward, and lateral pressures. Okay. Then we have seen the laws of fluid pressures. It depends mainly on the area of contact and so on what factors it is independent, and finally we discuss in the synopsis 3 as atmospheric pressure, the pressure exerted by atmosphere. Okay. So these are completely about the atmospheric pressure, measurement of atmospheric pressure by using the manometer, and construction. We have seen the video also. Right. So an example is given here, simple example is given for the solid examples. You can check in the textbook material about this. You can see once before going for the review. See here, a girl of mass 50 kg. A girl of mass 50 kg standing on pencil heels. Heel is then a shoe. Pencil heel, very sharp heel. Each of area of cross section 1 centimeter square. Okay. The heel area. Then the pressure exerted by a girl is dash into 10 power 4 Pascal. We have to do conversions. So what is the formula? Mass of the girl is 50 kg. Force exerted by girl is nothing but M into G. As per the Newton's second law, F is equal to mg. So mass is given, not force. So 50 into 9.8 we have to do. G value is constant. So we'll get the 500 Newton is the force. Okay. Then what he asked, area is given already. Each area is what? 1 centimeter square. As there are 2 hills are there, 2 into 1 centimeter square, we convert to meters. So 2 centimeters are by 1000. That's all. 2 by 1000 meters square. 1 centimeter is 100. 1 meter is 100 centimeters. So 1 centimeter is 1 by 100. Centimeter square is nothing but 1000. Okay. 10, sorry, not 100, 1000, 10. So we got this is the area in meter square. So force into force by area. So force is 500, area is this. Now cancelling, you get the 250 into 10 power 4 Pascal. But already 10 power 4 given here, we'll write only 250 in the blank. Right? That is the pressure exerted by the heels, the pencil heels of a girl of mass 50 kg. Right? There's some example. Now, we'll go for complete review of the chapter. What we learned from the beginning to last end. Okay? With all the definitions, you can note down also. But before that, let me show you one video on the entire topic. Video on entire topic of the pressure. Then we'll go for the all the important points what we learned. The points what we learned in entire chapter, right? But before that,
what is force? What happens when a force is applied to an object? While pushing, pulling, lifting, or hitting anything, we are actually changing the motion of an object. This change in motion requires force. So we can say that a push or a pull on an object resulting in its motion is called a force. Objectives. At the end of this lesson, you'll be able to define force, list the properties of force, understand the effects of force, distinguish contact and non-contact forces,
then about pressure.
List types of contact and non-contact forces, list properties of pressure exerted by solids, liquids and gases, list the effects of pressure on human activities, define atmospheric pressure.
Total chapter, what we have.
What happens when forces interact? If you choose a heavy box and try to push it, the box will not move. Now if you ask a friend to help in pushing it in the same direction, it moves. This experiment proves that the forces are acting in the same direction add up. Effects of force. Consider a thin rubber balloon and blow air into it, the shape changes. Then tie its open end with a thread. Now press the air-filled balloon, you will see again the shape changes. This is due to effect of force. When you play football, the football is kept in the center of the field. When you kick it, it moves towards the given direction. Similarly, in the kitchen, your mother makes balls from dough and rolls them into chapatis. In this case, she is applying
These are
force
all the effects
to
of
make them
force.
flat.
How force will affect.
Effects of force. One can change the direction of the object by applying suitable force on it. For example, in cricket, the speed of the ball hit by a batsman reduces to 0 when the fielder catches it. Also, if you kick a moving football, the speed of the football increases. Kinds of force. There are two major types of forces: contact forces and non-contact forces. Examples of contact forces are muscular force, force of friction, etc. Similarly, example of non-contact forces are magnetic force, gravitational force, etc. Contact forces. Can you push or lift a book lying on the table without touching it? Or can you lift a bucket of water without holding it? In both the cases, the answer is no. Generally, to apply a force on an object, our body needs to be in contact with the object. So we can say that contact forces are the forces which act on bodies when they are in actual contact. Basically, these are of two types: muscular force and force of friction. Muscular force.
The force of
When we
muscles.
push an object such as a box or lift a bucket of water, then the force is caused by the action of muscles in our body. This force is known as muscular force. Note that muscular force is always applied either directly through touch or indirectly with the help of a stick or piece of rope. For examples, cutting the vegetable or fruits with the help of knife, hammering of nail with the help of hammer, pulling a cart by horse. Force of friction. Do you know why a heavy box on pushing does not move? Why a rolling ball stops after some time? When an object moves in contact with another object, a force known as friction comes into play. Note that the force of friction always acts on all objects and its direction is always opposite to the direction of motion. The moving object in the animation gradually slows down and ultimately stops due to the force of friction. This shows that force of friction always opposes the motion of one body over another body in contact. Types of non-contact forces. The types of non-contact forces are gravitational force, magnetic force, and electrostatic force. Do you know why the leaves or fruits fall to the ground when they're detached from the plant? This is because of gravitational force. The force due to Earth's attraction is called the gravitational force. This is an example of non-contact force. Now, the force between two magnetic poles placed at a suitable distance is called the magnetic force, in which like poles repel, while the unlike poles attract each other. A magnet can exert a force on another magnet without being in contact with it. So, the force exerted by a magnet is also an example of non-contact force. Do you know, when we rub a tube through dry cloth and bring it near the thread is attracted towards the tube. This is because on rubbing the tube through the dry cloth, an electrical charge is generated on the tube. This is called the electrostatic charge. This is also an example of non-contact force. Pressure. Let us perform an activity. Take 5 wooden boxes of almost the same size. Fill them with scrap iron to make them heavy. Arrange these boxes on a wooden table, placing them side by side. See the impact of the push force from these boxes on the table. You will notice that the table remains normal and it is not affected by the push force, that is, weight of boxes upon it. Now, rearrange these boxes on the same table, placing them towards the center and one over the other. Now see the impact. In this arrangement, the table either bends or breaks under the weight of boxes. Can you guess why does this happen? Though the force applied in both the cases is same, But in the
Yeah.
first case, impact is less, and in the second, the table bends. This activity proves that both the force and its coverage area are important. The smaller the area on which the force acts, greater is the impact, and this phenomenon is known as pressure. We can also say that pressure is related to the force. Daily life example of pressure. Have you ever noticed that why school bags have white straps? Why sharp knife cuts better as compared to blunt knife? And why the tip of the needle is sharp? In our everyday life, we all experience the impact of pressure. A school bag has white straps so that the weight of the bag may fall over a large area of the shoulders of the child, thus resulting in less pressure on the shoulders. And due to less pressure, it is quite comfortable to carry the heavy school bag. A sharp knife has a very thin edge. It cuts objects better because the area of contact is very small. The force of our hand falls over a very small area of the object, producing a large amount of pressure. And this large amount of pressure cuts the object easily. Due to its sharp tip, the needle will put the force on a very small area of the cloth, producing a large pressure sufficient to pierce the cloth being stitched. Do liquid and gases also exert pressure like solids? Do you know what happens when you blow air into a balloon? It exerts pressure in all directions. That's why the balloon increases in size and shows equal enlargement in all directions. The same is also true for the liquid. It also exerts equal pressure in all directions. When a plastic disc is submerged in water, it does not fall down. It is continuously pressed against the glass pipe by the pressure of the water. This implies that the water exerts pressure in all directions. Air and our atmosphere. We know that there is air all around us. This envelope of air around the earth is known as atmosphere. Actually, air has weight and therefore exerts pressure. The pressure of the air upon the surface of the earth is called atmospheric pressure. Note that atmospheric pressure decreases as we go up and up. On an average, the weight of air on our head is 1 kilogram per centimeter square. Daily life experience of atmospheric pressure. In our day-to-day activities, we experience various instances of atmospheric pressure. Some common examples are sipping cold drink through a straw, dipping the nozzle of the syringe in the liquid, or filling of ink in fountain pens. Do you know what happens when you sip the cold drink? The air pressure inside the straw is reduced, and the air pressure on the surface of the drink pushes the drink up into the straw to reach our mouth.
After opening the cap.
In case of a syringe, the doctor dips its nozzle into the liquid and pulls the piston, thereby lowering the air pressure inside the syringe. Another example of ink-filled fountain pens that have rubber tubing, the rubber tube is pressed to push out the air from it, thus reducing air pressure inside the tube.
Right. So this is complete picture about our chapter, entire chapter. So what exactly the pressure, force, what we learned from the beginning, last 4 sessions or 5 sessions, the total explanation is given in a single video, right? So once again, we recall what we learned. So important points, if you want, you can note down also. Entire points here. First, what is pressure? Pressure is a force applied on surface per unit area. So formula, pressure is equal to force by area. Then units of pressure. The SI unit of pressure is Pascal. And 1 Pascal is equal to 1 Newton per meter square. Because force by area. Force is Newton, area is meter square. Right? Clear? That is about the pressure. Then effect of area on pressure. So means what happens when area increases or decreases. If area is small, pressure increases. If area is large, pressure decreases. Example, a sharp knife cuts better than blunt knife because it applies more pressure on small area. Simple example, one example. So many are there, one is given here. Right. Then pressure in liquid and gases. Liquid and gas exerts pressure in all directions. Example, water exerts pressure on the walls of the bottle. If you make hole to the bottle, water will come with a great pressure. Okay. Then last topic, atmospheric pressure. The air around us exerts pressure known as atmospheric pressure. That is the pressure exerted by air. Suppose when you are sitting in classroom now, around you air is there. Maybe you cannot see, but air is there. That air exerts some pressure on you. It decreases when you go higher the altitude or on mountain. When you go to mountains or when you go to the heights, flight. So as you are going height, the pressure atmosphere decreases because the air decreases. Right. So here you can see there's a instrument to measure the pressure. Even you might have seen in the vehicles, when you go for filling air, either in your two-wheeler or four-wheeler, they will check how much pressure is there inside the air by keeping such an instrument. It's a manometer, barometer, so many types are there. Right. So you can note down these points easily. Very important as a what we learn, you can keep writing, and what we learned so far. Right. The point number 1, point number 2, point number 3. Totally it covers total chapter. You can appear for the test number 8 easily. Note number 5. Right. Make it as the 5 points and write down first. So after this, a few more points are there before concluding the session, right? Now it is your turn to go through the worksheets and all. So with the help of your teachers, you can complete the worksheets during our month of IIT month is going on. I request all the teachers, subject teachers to in charges to keep following the students, whether they are following or not, maintaining notes or not. Completed. Right. So some more importance are there. We can see about what continuation. So applications of pressure. What is the next point? Applications. How the pressure is applicable in our day-to-day life. So broad tires of truck reduces pressure and prevent the sinking into soft ground. You can see trucks will have large tires or even 2 tires also, double tires. Why? Because they want to increase the area of contact so that the pressure will reduce. Next, suckers. The like suction cup. You can have a suction cup, will drink water or cool drink or milk. Work due to atmospheric pressure only. So syringe pull the liquid due to pressure difference. You can see a video also how the syringe will pull the liquid injection. Okay. Applications. Now pressure in daily life. High levels versus flat shoe. High heels, sorry. High heels versus flat shoe. High heels exert more pressure on ground because force is concentrated on the small area. Suppose if pencil heels or some heels, they have less pressure compared to the flat. So nail and pins, they have pointed tips to concentrate force on the small area, making easier to push into the surfaces. When you want to insert nail or pin, they have small area. Why? Because so that they can have the large pressure and they insert into the this one, right? That is point number 7. Right, 8. Factors affecting pressure. Force. More force increases pressure. Because you know, pressure is equal to force by area formula. Remember. So more force, that is, P is directly proportional to F. P is inversely proportional to area. Force more, pressure more. Second case. Smaller area increase in pressure and larger area decrease. Means they are reverse. When area increases, pressure decreases. When area decreases, pressure increases. Very important points. Next, pressure in liquid. Liquid exert pressure in all points of a container because it doesn't have any shape. When you are fill the liquid into any container, it exerts pressure on all the points. Wherever you make small hole, the liquid will come out with a great pressure. Pressure increases with depth. When you go to the depth, the pressure increases. Because from the formula, P is equal to H dg. Directly proportional to height. So when you go to the depth, the pressure increases. Right? The deeper you go in water, the more pressure you feel. When you go in for swimming also, you go to inside, you get the more pressure. Right? Then example, dams have thicker base to withstand the more pressure of the greater depth. Dams, you can construct the dams now. The last point, pressure in all direction. Air exert, pressure in gases. Air exert pressure in all direction like liquids. Right? We have seen just balloon. When you are blowing the balloon, we can find. Example, when a balloon is inflated, air inside pushes against the walls of the balloon. Vacuum suction works because of the atmospheric pressure. Suction cups, vacuum cleaners, all these works on the principle of atmospheric pressure only. Right? So note these 5 points also, which completely explains about the entire chapter. All the 10 points makes you clear about the total chapter, total concepts of a chapter pressure. Right now. So I made the total chapter into 10 points. So if you read the 10 points repeatedly, easily you can understand the entire chapter and you can appear for the exam with confidence. So starting from force to pressure in gases in 10 points. So probably when you meet next time, we'll go for the revision for the grand test. Right? Hope you are done. So some more is there? you can complete with this. How to measure the pressure, the very important point. So before closing the session, all the pressure can be measured, either it is a liquid or solid. A manometer measures the pressure in liquids and gases. A barometer measures the atmospheric pressure. Right. That is the 11th point. 12th, effect of atmospheric pressure. At high altitude means height, atmospheric pressure decreases, which can cause the difficulty in breathing. When you go to the high, sometimes happens. When you go to the super high over the flight, we'll get some suffocation. So they supply the oxygen masks. Means as you are going to the high, the pressure decreases. So boiling point of water is lower at high altitude because there is a less air pressure. So right then, applications of pressure in science and technology, not only daily life, it also helps in a science and technology. Hydraulic system like brakes in car use liquid to work. Then syringes, pumps and straws works on because of the pressure differences. Aeroplanes are designed to handle the change in atmospheric pressure at high altitude. They're designed like that. So airplanes are designed with a different shape and different facilities to face the decrease in pressure problem. So many others are there. Suppose when you go to the hydraulic machines for crushing the oil seeds to get oil. And similarly, hydraulic machines also, Brahma press, they are called. Even also they are used in the car wash stations. Car is placed over a platform and lifted with the help of the hydraulic pressure. So all these are the applications of pressure in our science and technology. Okay, so note all these 3 points. Right. Good to see Ramnagar branch, ECL Masterminds, Bhudevi Nagar, Mastermind Swarup Nagar, Mastermind Vatasiguda, and Pooja Reddy. I don't know which branch you are. Right. So that's all for today. You practice for all the worksheets of the chapter for the coming delayed test 8 exam, which is delayed. Maybe we can send the question papers within 2-3 days. Right. So that's all for today. Thank you, students. Have a wonderful day. Thank you.